Hi students, in this video we are going to discuss two problems on annual cash flow analysis. In the last lecture we discussed the present worth analysis. So basically what we did in the last lecture is if we have given cash flows for different periods, we converted all of those cash flows into one single cash flow in one single value, that was P, the present worth of future cash flows. We have been given A's, which is annual cash flows. We were given F. So if we have A, then we did P given F. We use P given A factor to calculate the worth of that cash flow, right? If F was given to us, we did P given F. Future value is given. What happens in the second year, third year, or maybe 10th year, the cash flow in the 10th year or 5th year, whatever year, when it is given to us and we want to find out its present value P, then we used P given F factor. So this lecture is very similar to what we did in the last lecture. Only difference is, last time we were interested in present worth, the P value. This time, if with the same different cash flows that are given to us, then we need to calculate the annual cash flow, the A value. We need to convert all different sorts of cash flows into one single value, which is A, annual cash flow. So that's why the name of the chapter is annual cash flow analysis. For example, we may have P values, F values, and we also may have A values. So different types of cash flows. So all these cash flows, can we group them together into a new A value or annual cash flow, right? So let's first read the first problem, and then it will make more sense when we work on this problem. So I'm gonna read this problem first. The survey firm of Myers, Anderson and Pope, MAP LLP Limited Liability Partnership, is considering the purchase of a piece of new GPS equipment. So basically the company MAP is interested in purchasing a new equipment, new GPS equipment. Data concerning the alternative under consideration are as follows. So all the cash flows related to that purchase are given below. First cost, the initial cost of the GPS equipment is $30,000. Annual income, the annual income generated from that particular equipment is going to be $8,000 per year. Annual cost for that equipment will be $3,500. Recalibration at end of year 4. So that equipment needs to be recalibrated at end of year 4. Right, so that's one-time cash flow, outgoing cash flow. That's an expense that needs to be put in for recalibration. So that amount is $4,000. And finally, the salvage value of the equipment. Whenever the equipment is discarded, salvage value, which is positive cash flow, because that is kind of income. So salvage value the company will receive from that equipment is going to be $2,800. So as you can see, a variety of cash flows are given to us. For example, first cost $30,000. What is that? That is a P value, right? That is present worth. We need to put $30,000 now into the equipment to be able to realize the remaining cash flows. Annual income and annual cost, they are A values, right? Because they are on an annual basis. Then recalibration at end of year 4, that is F value in year 4, and salvage value is also F value when for the year in which the equipment will be discarded. So that so far we don't know what year the equipment will be discarded, so we will look out for that information. So the next sentence is, if the equipment has a life of 8 years, that means salvage value will be at the end of 8 years. If the equipment has a life of 8 years and MAP's minimum attractive rate of return is 5%. So I, interest rate, minimum attractive rate of return is 5%. So we need to find out, given all this information, we need to find out what is the annual worth of the equipment. Annual worth. So before we go for the solution, I would like to introduce you to these three new terms: EUAC, EUAB, and EUAW. So what is EUAC? Is basically equivalent uniform annual cost. Equivalent uniform annual cost, right? Then EUAB is equivalent uniform annual benefits. So that's a negative cash flow there, equivalent annual. So converted modified cash flow in terms of A. All cash flows, all the cash flows in this expression will be negative. They are cost. EUAB talks about benefits, equivalent uniform annual benefits, and EUAW, the third term, EUAW, that is equivalent uniform annual worth. Basically, annual worth is nothing but the benefits minus cost. So EUAB minus EUAC, as you can see from this formula, right? So we need to find out what is the annual worth of the equipment. So basically we are interested in finding out the equivalent uniform annual worth. Okay, so for that, first we will focus on the cost and then benefits and then do the subtraction, right? So let's work on EUAC. EUAC is equal to 30,000 is the first cost of the equipment, 30,000, but that's a P value and we are interested in annual value, annual cash flow, right? So that is, if that is P value and we are interested in A, then we need to multiply that by the factor A given P. We need to multiply number 30,000 by A given P for interest rate 5%, which is given in the problem statement, and number of years N, which is the life of the equipment, is 8 years, right? So 5% is I and N is 8. So from the tables we can find out the A given P factor and then multiply 30,000 with that factor. So that is first. Now what are the other cost? So let's see 4,000. 4,000 is basically this cost here, the recalibration cost at the end of year 4, right? So that 4,000 is a F value, and we need to find out its equivalent annual cash flow for 8 years, right? So what we can do is we can multiply 4,000. First let's try to find out the P value for 4,000. Okay, we can do that. First we find out the P equivalent P value and then we convert that P value into A value. So 4,000 is F, so P given F, right? P given F, interest rate doesn't change 5%, but N changes here. N is 4 because it's at the end of year 4, right? So based on that we can find out the P value of 4,000 and then that will be so once we have that value, that is a P value, that needs to be converted into its equivalent annual cash flow, right? And not for 4 years but for 8 years. So we multiply that whole number by A given P factor. Interest rate 5% doesn't change, but the number of years 8, because we are basically interested in distributing that cost over the 8 years, right? So remember the difference here. We used 4 when we wanted to find out the P value. We used 4 because that was at the end of year 4, but now we know P value from this expression and we want to convert it into A value for 8 years, right? So that's why we change that number to 8. So that is that. So these two terms are cost. Are there any other cost? Let's see. No, there is one more cost there, which is 3,500. But what we will do is we will subtract that is annual cost already, that is already A number. So we will subtract that from annual income. So 8,000 minus 3,500. So let's not worry about that for now. Okay, so the cost that we have calculated based on the first cost and based on the recalibration of the year 4. If you want to add annual cost as well there, that's fine. You can add, since this is already A value, you can just add plus 3,500, right? Since it is already a value, you don't need to use any factor for that. So that will be our real EUAC. But I am not really worried about that right now. I will explain you why. But that, if you do that, that's not wrong. That is correct also. So that was cost part. Now let's focus on EUAB, the equivalent uniform annual benefits. So what kind of benefits or what kind of positive cash flows we have? First is 4,500. Where did it come from? Basically, I subtracted 3,500 annual cost from annual income 8,000. So that gave me 4,500. So if you would have added the cost here 3,500, then you need to add full benefit, which is annual income 8,000 here, right? So that's if you add 3,500 there, then you add 8,000 in this EUAB formula. But since we have not added annual cost in the first expression, we can directly write down here 4,500. So that is that. That's one positive cash flow. Now let's see what else we have. We have a salvage value, which is a positive cash flow at the end of year 8. So that is F value, right? So we will look into that. So basically that value is going to be 2,800, which is F value. We need to convert it to A. So A given F factor, 5% interest rate, number of years 8, that doesn't change. So that gives us EUAB value 4,793.16. Okay, so we have costs, we also have the benefits. Now it's simple. We need to find out the EUAW, the annual equivalent annual worth, so which is EUAB minus EUAC. So 4,793.16 minus 5,150.087 or 09. So if we do the subtraction, we get this number 356.93. So basically the equivalent annual worth is negative, right? So if the company is considering to buy that equipment, what would you recommend to the company? You would not recommend buying that equipment because that is causing a equivalent uniform annual worth which is negative, so which is lost. So I would suggest not buying the equipment. So hope this makes sense to you. This time I am not going over the compound interest tables, which you can find out from here again. So I already have those values. Okay, so that was problem 1. Problem 2 is not very different or difficult. It's more of the same. Let's read the problem first, and then we will try to address it. A company must decide whether to buy machine A or machine B. After 5 years, machine A will be replaced with another A. So now there is a decision making problem. There are 2 machines, and we need to select one of these 2 machines. From the way the problem is written, after 5 years, machine A will be replaced with another A. That means it looks to me that machine A has a life of 5 years, right? Nothing is said about machine B, so we will assume that it has a more life than machine A. So let's see. Let's see what else is given to us. So machine A first column, machine B second column, and we have given some numbers here. The first cost, the cost of the machine. Machine A is $10,000. Machine B is $20,000. Right? So machine B is costlier than machine A. Then annual maintenance cost. So that first cost is P, basically value P, right? Annual maintenance, since it is annual, it is already A. Annual maintenance for machine A is $1,000. Machine B has 0 maintenance, which is a good thing, right? Even though the initial cost of machine B is high, it has zero maintenance, that is good. Then salvage value is 10,000 and 10,000, so both have the same salvage value, but they don't necessarily have the same useful life. Machine A has 5 years, which we already know from this statement, and machine B has 10 years, right? So machine B lasts longer. Now we need to make a decision whether machine A is good or machine B option is good. With the minimum attractive rate of return 10%, so 10% is I for the company, which machine should be purchased, right? So we will solve this problem for 10 years because that's the useful life for machine B, so we will solve for 10 years. What we need to find out is we need to find out the equivalent uniform annual worth for both the options, for machine A and machine B, and based on that we will make a decision. So let's work on machine A. So EUAW for machine A is first cost is 10,000, so minus 10,000, right? Negative 10,000 multiplied by, since this is a p value and we are interested in finding the equivalent annual worth, we convert that into A given p factor we use. 10% is the interest rate and 5 is given to us. 5 is the number of years, right? So that is 5 minus what else is given? The annual maintenance, which is already A, so we don't need to multiply that with any factor, which is $1,000, right? So that's there, minus 1,000. Now let's talk about the 10,000, which is the salvage value of machine A, right? Salvage value is 10,000. That means A given F. 10,000 is future value, right? 10,000 is salvage value after end of its useful life, which is 5 years. So that we need to convert it into A value. So A given F, 10% and 5. So we solve that expression. We use the compound interest rate tables to get these values, and we solve this. The answer here we get minus $2,000. So we did this problem for the first, at least for the machine A, for 5 years. For 5 years, considering the machine life of 5 years, our equivalent annual worth, which has to be negative because most of it is cost, so it's minus 2,000, and we are replacing machine A after 5 years with another machine A, but that will not change our equivalent annual cash flow. That will be minus 2,000 for the next machine as well. So that sounds good so far. Now let's do for option B. So for option B, EUAWB, minus 20,000 is the first cost, which is here, that is P, so we need to multiply that with A given P factor. Interest rate doesn't change, but the number of years change from 5 years to 10 years because the life of this machine is 10 years, right? So that's the only difference here. Plus 10,000, which is salvage value. Salvage value is same, that is a future value, so we need to multiply that by A given F factor at 10% interest, and 10 is the useful life, right? And that gives us minus 2627 is equivalent annual worth, which is there if I use the values from the table again for A given P factor and for A given F factor. We get minus $2,627. So that is equivalent annual worth for machine B. So looking at these two options, it looks to me that option A is cheaper because its equivalent annual worth is less. Minus 2,000 is less than minus 2,627, right? So looks like option A is cheaper, so therefore machine A should be purchased. Okay, so that's I hope these two problems make the ideas on this chapter clear about annual cash flow analysis. Basically our goal is to, no matter what kind of problem we are working on, the goal in all the problems based on this chapter is to find out the equivalent uniform annual worth. So if one option is given, we can find out EUAW. If two options are given, we can find out equivalent uniform annual worth for both the options, and then compare the options. So that's the goal of this chapter. Okay, with this I will stop now.